we have to deal with some solenoids. So I want to just do a quick little solenoid art show. And you folks need to be able to interpret or draw solenoids. And solenoids, of course, are these current carrying wires. And so one way to draw a solenoid is to do it cross-sectionally. And so this is a cross-sectional solenoid. Look at that. Sliced it right down the middle. Coils that are going towards us on the left, coils that are going towards or away from us on the right. And so we could call this a 2D cross-section. Now, what's going to happen in terms of the magnetic fields around these guys? Each individual wire is going to have a magnetic field on the right-hand side that's orienting clockwise around that wire. That means down on the right and up on the left. And these guys on the left-hand side are going to have magnetic fields that are going down on the left and up on the right. Check with your right hand. If you don't believe me, remember to use your right hand, not your left hand. Okay? You know who I'm talking to right now. All right. Now, you know that these magnetic fields can't really cross with one another, but what they can do is kind of merge together. So would you imagine, like, there's some merger going on here. They sort of mash, right? And so we got like this downward general thing going on the left-hand side of this cluster of coils and this upward general thing going on these right-hand coils. Would you believe that that means that interior to the solenoid, the magnetic field is generally going upwards? See what I'm saying? And as you get further and further away from the wires, the field kind of smooths out. So we end up having this nice, shapely magnetic field coming out of the north end and coming back around to the south end. Okay, that sort of field smoothing. Now that's a schematic 2D way of drawing this. Then there's people that are like, I'm an artist. My mom told me. And for those people, maybe you like the garden hose model. This is a 3D thing. Look at that. You guys ever read any Le Petit Prince? The Little Prince? Suddenly I'm like, oh, is this a snake eating a hat or something like that? Anyway, it's not. It's a solenoid. And so we got a current coming in. If you don't know The Little Prince, I'm so sorry. You should read more French naivete or something. All right, so current going away from us. Look careful. It's going to go away from us on the right-hand side, and it's going to come towards us on the left-hand side. And you're like, oh my gosh, this is actually the first one redrawn as a garden hose. You guys see what I'm talking about? 3D. And of course, that means that I should be able to use this one. I built up. Essentially, I built up the second right-hand rule for solenoids using the first right-hand rule for straight conductors. This one, I'm just going to jump straight to the second right-hand rule for solenoids so that if I wrap my fingers around this garden hose in the direction of the current, then the thumb is going to point towards the north. There's the south. And then there's yet another one. So this is the 3D hose model. Then there's another one. And this is the one that you see in a lot of textbooks. It's actually kind of a merge of the two. It doesn't require any artistic talent. Look at this. This is a solenoid. X is away, dots towards. Didn't even put circles around the X's or dots. That's how basic I am. And you end up having the exact same pattern. Okay. Now this is our schematic version. And I would call this kind of a hybrid of the two. And so I just wanted to get these guys down on paper so that if you encounter them in homework or online, you kind of knew that they're all the same thing. Cool.